Hello friends, I'm Nathan Daniel again, and today we'll be seeing the experiment number 6, which is assembler for SIC. So SIC is an architecture where object code is being converted to, source code is being converted into machine equivalent code, that is object code. So this is what, now let's see the program. So this is the program, assembler of SIC. It's a Java program. Uh, okay. So here we'll be needing actually two files. I'll be telling that to you later. So here we need is importing java.buffered reader, buffered writer, file writer, IO exception, hash table. So file reader, file writer is basically used because external file is being applied over here. Like it reads from the external file. So hash table is just compares it with its own hash table. Inbuilt hash table. Buffered reader is just storing the the, the buffer memory, the memory which is being read, right, and written. So that's what happens. Public class, all this will start hash table op. Okay, so hash table op is equal to ready op table. Hash table sim is equal to new hash table. So this all this we're just inputting it. Here what we do is buffered reader br is equal to new buffered reader. So the memory is being stored in D drive input.txt. So I'm opening the D drive. Okay, this is the D drive and input.txt. As you can see, I've created an input.txt file. In this we have a program. This is a program. Okay, it's a microprocessor program. So that's the program. So that is input.txt. Inter.txt. So in inter.txt, what we do is like inter.txt. So in inter.txt, it's like copy start. It's a program. Okay, it's another program. So let's minimize that for a second. String line title equal to this. Okay, so anything we are just initializing this. LC 0 start, we're just starting all this, and line dot contains start. So if a line contains start, so it starts the program. So then it starts reading it in the buffer and then splitting it. Title start is integer dot pass int, that's the same thing. So it's the same thing. Then start is equal to integer dot pass int. Okay, that's what I told. So LC is equal to start. So starting the assembly compiler, start is equal to 0. Then write it in this. So then if it's end now, then finish it with the opcode and symbol table and all. So it compares with the symbol table. Pass table, write integer to hex string, LC, etc., etc. Int length, LC start. So br dot close wr, so buffer read close and write close. So it finishes. Once it finishes, it just goes on to the next file, which is inter.txt. So this I'll be showing you as inter.txt. That's what I showed you right last time. So that's what happens. So then it compares it with the inter.txt and it does something. It's like 2626 something like that. End. Once it ends, it passes it to the next compiler. That is line of the same thing. Okay, br1 dot close. Now it goes into the private. Private mode means no one can access it except the person who's inside. So okay, so that's the thing. Object code is T expression. That's the up arrow. 03 string C. Line dot split. If op dot contains key C of 2, all this is the same thing. Object code and op dot get C of 2, integer 2 hex string. So it's just code to like put it to the next string. Okay. So SOPLN object code else if resw. Okay. Else if line dot contains resb. So reserve word, reserve byte, and word. So these are the three things that happens. Object code. So all this is basically the same thing. It just keeps reading and writing. So now let's just check the output. Yeah, so successfully it has run. As you can see, this is what is printed. Okay, from this it has printed that. So from input.txt it took this program, okay, and it has printed this program, this program in the background. So that's what is printed using the opcode table. This is the opcode table: STA23, LDA00, STX45. So that's what they have done. So that's what is done. So thank you, friends. This is the experiment number 6 of the compiler lab, which is the assembler of SIC.